Welcome to Introduction to Machine Learning, which is the first session of the Explore ML series. And this is a session that is in collaboration with Google Crowdsource as well as DSC-ASEB. I'm Sneha B and I will be your speaker for today. And I am an Explore ML facilitator at Google Crowdsource. So today's session is going to be all about a basic introduction to machine learning. We'll understand what exactly machine learning is and how it is different from our traditional rules-based approach. We'll also understand how exactly we take a small idea of machine learning or any project that we have, and what are the steps that are required for us to go from this idea to actually implementing that project. So let's get started. So our first thing we'll do today is watch this wonderful video on machine learning.
Our ability to learn and get better at tasks through experience is part of being human. When we're born, we know almost nothing and can do almost nothing for ourselves. But soon, we're learning and becoming more capable every day. But did you know that computers can do the same? Machine learning brings together statistics and computer science to enable computers to learn how to do a given task without being programmed to do so. Just as your brain uses experience to improve at a task, so can computers. Say you need a computer that can tell the difference between a picture of a dog and a picture of a cat. You could begin by feeding it images and telling it, this one's a dog, that one's a cat. A computer programmed to learn will seek statistical patterns within the data that will enable it to recognise a cat or a dog in the future. It might figure out on its own that cats have shorter noses and that dogs come in a larger variety of sizes, and then represent that information numerically, organising it in space. But, crucially, it's the computer, not the programmer, that identifies those patterns and establishes the algorithm by which future data will be sorted. One example of a simple yet highly effective algorithm is to find the optimal line separating cats from dogs. When the computer sees a new picture, it checks which side of the line it falls on and then says either cat or dog. But of course there can be mistakes. The more data the computer receives, the more finely tuned its algorithm becomes, and the more accurate it can be in its predictions. Machine learning is already widely applied. It's the technology behind facial recognition, text and speech recognition, spam filters on your inbox, online shopping or viewing recommendations, credit card fraud detection, and so much more. At the University of Oxford, machine learning researchers are combining statistics and computer science to build algorithms that can solve more complex problems more efficiently, using less computing power. From medical diagnoses to social media, the potential of machine learning to transform our world is truly mind-blowing. To find out more about machine learning, visit Oxford.
Alright, great. So all of these answers made a lot of sense and they are actually correct. So machine learning is if you just take the name as it is given to you, yes, it is a way that machines can learn. It's a way that machines can identify patterns, as someone so rightly mentioned, for it to recognize something. As so in this video, we saw the example that a machine learning model was used to recognize an image of a dog from the image of a cat. So when we look at when you look in the street, maybe look at a cat or a dog, we know that it's a cat and we know it's a dog. Now, how do we know this? Because we have learned from a young age that, okay, this is how cats look. This is how dogs look like. These are the features that differentiate a cat from a dog. So this is how we have learned, or we have been trained to differentiate a cat from a dog. Now, this same learning that we have had, we're trying to incorporate the same thing into a machine to let it learn these different patterns and understand and differentiate between a dog and a cat, or it could be any other task that you wanted to do. So that's what we're trying to do. We're trying to use different algorithms. More of all of these terms will be explained in this session and the forthcoming session. So we're trying to use certain algorithms that allow this machine to learn on its own and classify the two different things. So that's basically what machine learning is. Okay, let's move on. All right, now let's play a very interesting game. So in the beginning of the session, I'd asked all of you to download the Crowdsource app. So the link for that same is in the chat. If you haven't already, please download the app. And once you download the app, open it and go to this particular option known as Smart Camera. So once you go there, here's what you do. Take the Smart Camera and point it at any object in your house. Maybe you're sitting in front of the laptop, so you can point it at a laptop. Or you could perhaps point it at your bed. You could point it at a mirror, anything. Just point it at one object and see if it identifies that object or not. So this is what it will look like. You open the smart camera and you can point it at an object, and when you click on that particular focused frame, it will let you know what the object is. So you can either type in yes if it's recognized the object correctly, or you can click on no and add a description if it's identified it incorrectly. So let's have a quick discussion. Now, how do you think this image identification works? But anything at all that you understood about this?
I actually think so that it actually scans the object and tries to go through its data that what it's look like.
Yes, exactly. So if I had
It
to
goes through each and every pixel of it and gets to know the data.
Wonderful. Yeah, exactly. That is a really good answer. So both of you answered really well. That is exactly what it does. What it tries to do is, as both of them mentioned, it already has a lot of data with itself. So it has a lot of data. And now, how does this identification exactly work? Like I mentioned before, each object has their own set of features. There are certain defining features that characterize or help you differentiate and identify that particular object. So that's what our machine learning model does. You can think of it working in the like similar lines of a human eye. So what it does is it tries to look at the object. So the answer to the second question, if I were to say how it's recognizing the objects exactly, it's basically using this camera type system that's there. That is the smart camera or the camera that you have in your phone. It's using that. It's trying to focus its area around the object you're pointing, and it's going through the list of data that it has, and it's trying to match an object that has similar features to this, and then it's giving you a result. Now, in so many cases, many of you had incorrect answers, and that could be because there was a feature. See, machine learning models are never perfect, and neither are humans. So there must have been somewhere it would have gone wrong. Maybe it was not trained properly, or maybe the picture was not taken properly, maybe it didn't focus properly. There are many different caveats to this, because of which it could go wrong. But this is in essence or on a surface level of how image identification works. So let's move on to the third question. How do you think we can program this?
Should give the similar data to the machine to learn and then.
Wonderful. Yes, exactly. And let's move on to one more game. This game is called QuickDraw. So I think the link for this game is already there in the chat. So you can go open this link and try playing this game on your own. So basically, you'll have to click on Let's Draw. So maybe I could show it to you here, although I'm not very good at drawing. So you just have to click on Let's Draw. And if it says roller skates, right? You just have to try your best to draw.
I see necklace, or mustache, or eyeglasses, or fire truck.
Okay, I'm not able.
I see scissors, or school bus, or skateboard, or cannon. I see bus, or van. Sorry, I couldn't guess it.
Yeah, so it's something like this. Maybe you can try and let me know how it went for you all. So let's take a look at the data that is there behind this. So if you look at this, over 15 million players have contributed millions of drawings here. So you can look at all these different types of drawings here. For each, so if you click on Apple, there are so many different ways that a person has drawn Apple. So what this model does is that it takes each of these. So all of these are Apple. These are different ways that people have drawn Apple. So the model has used all of this data and it's trained on that to understand the distinct features that, okay, so an apple, you have it, maybe sometimes it could be bitten and not a whole apple, but mostly it looks like this. You have a circle and there's a dent on the top, then you have a stem and leaf that's sticking out. So there are some half-eaten apples, there are some complete apples, and so it uses all of this data that's given to it from the people, and it tries to identify the features that make it different, the features that basically uniquely help us identify an apple. So this is QuickDraw data. So this, you can look at it and see the different ways in which people have drawn one particular object and how that has been used to train a given model. So if you see on the screen here, we're talking about carrots. So these are different ways in which people have drawn carrots, and the model has used all of this to learn how to differentiate or how to identify a carrot. So now this brings us to a very, very important discussion of something known as a rule-based approach towards any problem versus a machine learning approach to any problem. So what exactly is a rule-based approach? Now, Lakshman had answered in the chat that we use multiple ifs and else. So this usage of if and else, that is what is a rule-based approach. You can think of a rule-based approach as an approach where the programmer is giving the computer all the rules. So let's say, like as you can see in this code, okay, let's say that you want to identify an object that has a height of greater than 10 meters and it's of the color blue. So you write code like this. So if object of height is greater than 10, then print yes. If object of height is less than 10, print no. If object color is blue, print yes. If object color is not blue, print no. So we write like if and else's to basically identify objects here. So that is a rule-based approach where we are the programmers. We are giving the computer rules. We're giving them a set of fixed rules. They cannot make their own rules here. The computer has no provision to make its own rules here. We as the users or the programmers are giving the computer these rules and we're like, okay, so if this satisfies, then you print this. If this doesn't satisfy, then you don't print this. So if a condition is satisfied, perform a particular task. Otherwise, don't perform a particular task. So that is what a traditional approach or a rule-based approach is. So as is with any problem, when you have a particular problem, you first understand what the goal or the solution of that product should be. This is how we normally approach generally any problem. Now with rule-based, designers and engineers, they develop the flow and the logic of that particular problem. So they develop the rules that are required for you to identify or solve that particular problems. All the rules, how many ever rules they are, as Lakshman mentioned, they're given as a set of if and else statements. If this, then do this. If not, then don't do this. So there are many if and else statements that are involved in this. You can think of it like the programmer is giving the computer a manual or a rule book, and it has to exactly follow that rule book. You don't have to do anything more than following that rule book. So then the programmers themselves will try to modify these conditions, will try to make it in such a way that the program can work better. So that's what we refine until the goals are met. So that is a rule-based approach. Now, let's look at how machine learning is different from this rule-based approach. So machine learning, again, the first thing that you do is you finalize what the goal that you want to accomplish for that particular problem is. Then you do not tell the computer any rules. You absolutely do not give any rules to the computer. You just give it a bunch of data. Suppose, okay, let's go back to that example that was given in the video. There, they tried to use a machine learning model to differentiate a dog and a cat. So just think of this machine learning model as we're putting this machine learning model in a room, and this room is filled with pictures of dogs and cats. We're not telling it what a dog looks like, what a cat looks like. That information is not at all given to the computer by us. All we are saying is that now you look at this dog and cat and then you identify what is the difference on your own. We are not going to give any sort of help to that particular algorithm. So the machine learning model on its own learns or trains itself from this data and understands the differentiating factors, what makes a dog different from a cat, and learns on its own. We're not framing any rules. We are not saying, okay, the feature of a cat is this and this. The feature of a dog is this and this. If this feature is met, print cat, else print dog. We're not saying any of that. The computer on its own is learning all this. So if you can see here, this is again with reference to the QuickDraw game that we just had. So these are the different data that's given to the machine by the users. So this data is used by the model or the neural network here, and it trains on this given data and it tries to identify the right match. So we as the programmers are just giving the data. We're mainly giving like an algorithm or a way for it to understand this data, but we are not telling or giving any rule book or a manual for it to follow through and do accordingly. It just explores on its own, understands this data and gives you the right output. So that is the difference between a rules-based or a traditional approach versus a machine learning approach. So this is a very important concept. Can anyone tell me why machine learning is important? Like if we already have a rules-based approach, why do you exactly think that we need machine learning? We need machine learning because if I come to you with a problem and I say, hey, build a model that will help me recognize a dog and a cat. If you were going to use the traditional rule-based approach, then you will have to write a multitude of if and else conditions Because dogs and cats have some similar features, but also many different features. So you will have to write an if and an else for each of these features. And that's going to take a lot of time, and it's going to make everything very complex. So like they said, to ease our work, we use machine learning. So in machine learning, we just have to provide a lot of data, and the machine, from that data, the machine learns on its own. So rules-based approach, as all of you mentioned, the rules are defined by the programmer, and the improvements come from the algorithm that we are giving to the computer to solve that particular problem. So that is a rules-based approach. While a machine learning approach is an approach where the machine basically learns patterns from the given data. And any improvements that comes is a part of basically giving additional data. So machine learning is one process that is heavily data dependent, you can say, and it learns from that data. While rule based is, as the name suggests, you give a rule to that particular computer to solve a problem. And each of these has its own benefits. So as we saw in this quiz, there are some problems that really don't require machine learning. They can be solved with rules-based approach, and that is what makes the problem get solved in an easier and a faster method. So you don't really need machine learning for a lot of cases. All right, now let's move on to the next topic, which is something called an idea to implementation. So what are we going to talk about in this section? Basically, any project, any problem always starts with an idea. And how can we take that idea and take it through multitude of steps and help you implement that idea to get a proper solution? So even a machine learning problem always starts with an idea. So if you think of the dog and the cat classification, the idea was to classify dogs and cats. And then there are different steps that are involved for you to take it from this idea to actually allow you to implement it. So to understand it better, let's watch another video.
Suppose you have a great business idea and you've already gone through the effort to frame it as a machine learning problem. What next? How does your idea become a working machine learning solution? The process has 3 phases: data, modeling, and production. In the data phase, you identify the input data that your machine learning system needs to make successful predictions. Data may come from databases, log files, web pages, and even other machine learning systems. Once you identify data inputs and sources, you use statistical tools to draw insights about the data. The better you know your data, the more useful hypotheses you can make. Data rarely comes in an ideal state. Data needs to be collated, possibly by joining different data sources, and cleaned for the machine learning model to work optimally. Cleaner data results in better predictions. For a machine learning problem, you start with the input data and convert it into features. Features are key properties of the data. For a supervised machine learning problem, you transform the outcome into labels. Labels represent the intended output of the machine learning system. Joining data sources, cleaning the data, and engineering the features and labels takes time. Plan on spending a large portion of your time in the data phase. Modeling phase. Along with the features and labels, you set up the kind of machine learning system needed, called the model. Researchers have created all sorts of machine learning models, from simple to complex. Some models classify data. Other models predict numeric values. Tools like Google's TensorFlow support many types of machine learning models for various uses. Before a model can make predictions, it needs training, which is like sending the model to school. First, there are lessons to learn from the data. Along the way, there are quizzes to check knowledge and correct any misunderstandings. In the end, there's a final exam. When training the model, you split the data into 3 sets: training, validation, and test. The training set corresponds to lessons. Here, the model processes data for the first time. It starts to infer patterns in the data to help make predictions. After you've trained the model once, you quiz it using the validation set. Based on how well the model does on the quiz, you may decide to adjust the model settings, or hyperparameters, which are like dials and switches for changing the model's behavior, and retrain the model again to give it the quiz again. The goal is to iteratively find settings that provide the best model quality on the validation set. When the model meets your success criteria, it's time for the final exam. Feed your model the test set. If the model predicts well, it passes the course and is ready for real use. Once your ML system is ready for the world, it's time to move the system into production. For starters, your system may need integration into a product. You need to figure out what this integration looks like and whether your model interacts with users. Models may need retraining on a regular basis with new data to pick up on new patterns or trends. This training could come from new data sets or from interactions with users. The system needs monitoring. This means tracking system outages, errors, data processing volume and speed, and how successfully it predicts results. Machine learning systems also require maintenance. As with any production system, this means fixing bugs, adding features that didn't make it into version 1, and the like. Machine learning specific maintenance could include testing other models and settings to see if performance improves.
Alright, so I do understand that there was a lot of information that was given in this video. So let's break it down. The first important thing for you to understand is that the process of taking an idea to implementation has three main stages. Number one is the stage that's related to data. Number two is the stage that's related to the model. And number three is the stage that's related to production. So most of the time for any machine learning engineer or any data scientist is actually spent on data, because data, so as we've seen before, a machine learning approach is heavily data dependent. So it is pivotal for everyone to get the correct data in the right format. And only then can you go on to build models and put it in production. So the most important, the taxing phase of a machine learning production is collecting data. So you need to make sure that you collect the right amount of data. Now this data can be it could be from anywhere. You could take it from a database directly, or you could take it from a website. It could be in many different formats. Maybe you want to combine different formats together. Then what you will have to do is that you find a lot of missing values. You find some data that is not formatted. Like for example, if it's a number or it's a currency, it's not given as a currency. It's rather written as a text. So that's not in the right format. So you see a lot of this, and this will greatly affect your model's performance. So if you want a model to work well, these corrections must be followed through. So this is known as cleaning a data. So like they mentioned there, you take some data and what you do is you extract features from that data. Now, once you extract features from the data, you may not always have such clean or pristine data. You will not always have all the features that are available, or you may not always have all the features that are correctly formatted. So what you need to do is that whatever data you collect from whichever source it may be, you need to spend a heavy amount of time cleaning it, because the better and the best way you clean it, that's how it's going to affect your model. So if you don't clean it well, your model will not perform very well, because it's learning on incorrect data and it won't be able to understand the patterns that are involved or the features that are involved in this data. So that was about data. And briefly, they mentioned a word called supervised. So I'll mention this in brief and we will go over it again in the next session. Supervised machine learning models are of two types. So one is a supervised machine learning model. Now there is an unsupervised machine learning model. So a supervised machine learning model is one where the data is labeled. So let's take, for example, the cat and the dog example. So we know that when we're giving the model data, we know the picture of a cat is a cat and we know the picture of a dog is a dog. We just want the model to learn it on its own and predict it. So there we're giving it labeled data. That is, we know, or we have already labeled this data as cat and dog, and we just want the machine to understand the features that are different and be able to predict on its own what is a cat and what is a dog. Now, unsupervised is that we give a bunch of data. We don't tell the machine, or we don't specifically label and tell the machine that this is a cat and this is a dog. We just give it a whole flood of data, and it on its own has to look at these images, understand that there's a difference, find out what this difference is, and then on its own understand that, okay, this is the difference of the features. These are some specific features. So this makes it a dog and this makes it a cat. So this is supervised and unsupervised, and I'll again come back to this in the forthcoming session. So that was all about data. It's a fact, actually. IBM has done this particular research, and they've understood that 80% of a time for a machine learning engineer or a data scientist actually goes in data collection. Because the fine-tuning a model or making a production better is easier, but collecting data is very difficult, and cleaning that data, making it correctly formatted, making sure that you don't have a lot of missing values, or if you do have missing values, how to deal with these missing values, find the most optimal strategy that will work for your problem. All of this takes a lot of time. So if you're ever planning to work on a machine learning model and you're planning to collect the data on your own, you will have to spend a lot of time cleaning and correcting this data. So that's all about the data phase. Next, we have the model. So like I said, think of this model as a black box that does whatever task you wanted to do. Whether you wanted to classify between two images or whether you wanted to predict some number, it could do whatever task you ask it to do. Now for this model, what you have to do is train a model. And like they mentioned in the video, training a model is like sending a model to school and making that model learn from the data. So now we have the data which we collected in the data phase is split into 3 different divisions. So number 1, it's called a training set. So this training set, think of it as what teachers teach you in school. So teachers teach you something in school that corresponds to the training set. So we are teaching the model that, okay, so learn from this data, learn on your own from this data, learn from here. Now, validation set is, let's say, before an exam, you will go through some material. So you will go through whatever your teacher has taught you, and maybe you'll go through some last year's papers of something. So that is validation. You're not exactly going through the questions that come in the paper. You don't know that. You don't know what's going to come in the final exam. But you're just going to go through everything that is similar. So that is a validation set of data. So this validation set of data will help it prepare for the testing phase. So testing is the most important phase. Testing is a phase of a machine learning model that will let you know if that model is ready to work in the real world, if that model is ready to face different and new kinds of examples. So what do we do first? Like how a school teacher teaches you or how the college professors teach us, the model is trained on the training data. Then what do we do before an exam? We learn from different textbooks, different resources, from past year papers. So think of that as the validation set. So the model is preparing for its final exam using this validation set. It's trying to think of all the possible cases that could occur in the final exam. Now the final exam is known as the testing phase. So some data is given to the testing during the testing phase. That is the last section of the data is given to this model during the testing phase. And if it works well, if it makes good number of correct predictions, then it is passed. If it's not, then it goes back to training, goes back to validation, and again comes. So if you fail a course, what do you do? You redo that entire course because maybe you have not understood the material that's given to you. So same thing happens. The model goes through all the steps again, and it's tried again and again until you get a good or a satisfactory result. So that's about the model and how whatever data you got, that is split into 3 different sections: training, validation, and testing. Now, once your model has been tried and tested, it's finally passed and it has good accuracy, it's being able to identify the testing data and it's being able to properly do the task you're giving it to do. So let's keep the recurring example of classifying dog and cat. So maybe you gave it certain images to train on, then you performed a validation testing, and now you finally did a final phase of testing, and there it was able to in most cases, identify dog and cat. Now what you do is you open this model out to the real world. So you basically send it into production. Now after you send this model into production, it will not always be stagnant there. There may be cases where it has to be retrained. So if you think about this QuickDraw, right? So QuickDraw was once not a website like this. It was just a model that was in its training, validation, and testing phase. Once it did well in the testing phase, that's when they decided to deploy it into this website or deploy it into what was called in the video as production. That's what it's called, the production phase. So once it's in production, what happens is that in some cases it may be wrong. In some cases, whatever you drew may not be identified correctly. Maybe you drew it very well, but it was not able to identify it correctly. So what you do is you give a feedback saying this is maybe you drew a carrot and it was not able to identify it correctly. So you say this is a carrot, was not able to identify it correctly. So then from the user experience, the model is getting data again and it's able to get trained on that particular data all over again. So that's what happens in production. So once it's set into production, it's not just stagnant there. It will still keep getting data. Either it would get, so this example that I mentioned, it is getting data from user experiences. It could also get data from other databases that's provided to it. And there are many ways for it to continuously get data. So on this continuous data, whatever it gets, it continues to train itself and basically make itself better again. So that is the 3 steps of idea to implementation. That is, you have data, you have the model, and you have the production. So if you look at this here, so if you focus on, so whenever a problem is given to you, suppose a user has approached you with a problem saying, I want a faster or a better way to differentiate a dog and a cat. So that is the user's problem. So then you define the objective of the problem. Okay, the objective of this problem is to differentiate a dog and a cat. Then you start collecting the required data. What would the data here be? Images of dogs and cats. So you start collecting these images of dogs and cats. And like I mentioned, you train and test the model. So you use the training set and the validation set for basically training the model, and the final exam, which is the testing phase. And then you predict and evaluate the model. Check, okay, how well did it perform? Was it able to identify a dog and a cat? Now, if it was not, you can either go back and collect more data. Even after you collect more data and you do it again, it's still not giving you good results. Then what you do is you go back to the user. You ask the user again, hey, could you repeat your problem again? Maybe I misunderstood it. So then the user will again repeat their problem. So you correctly understand their problem and you start this process again. So unless and until you get good results with your model, you will do this step again, or you will go all the way back to the first step. So it's very important to first focus on the user and define the objective, define the problem statement, or define exactly what problem you have to solve. And like I said, it's vital for you to collect the right data. So that's about the machine learning process. There are 2 more videos ahead, and after that we will be wrapping up the session. So one video is about something called machine learning bias. So that's a very informative video. And the other video is about how machine learning basically promotes privacy. Like, machine learning works on data, right? And some data might be confidential. So how can you deal with this confidential data? It's very small and informative video. So before we get to that, any questions on this video and basically this idea to implementation step? All right, we'll just quickly watch those 2 videos and wrap up today's session. All right.
Let's play a game. Close your eyes and picture a shoe. Okay, did anyone picture this? This? How about this? We may not even know why, but each of us is biased toward one shoe over the others. Now imagine that you're trying to teach a computer to recognize a shoe. You may end up exposing it to your own bias. That's how bias happens in machine learning. But first, what is machine learning? Well, it's used in a lot of technology we use today. Machine learning helps us get from place to place, gives us suggestions, translates stuff, even understands what you say to it. How does it work? With traditional programming, people hand code the solution to a problem, step by step. With machine learning, computers learn the solution by finding patterns in data. So it's easy to think there's no human bias in that. But just because something is based on data doesn't automatically make it neutral. Even with good intentions, it's impossible to separate ourselves from our own human biases. So our human biases become part of the technology we create in many different ways. There's interaction bias, like this recent game where people were asked to draw shoes for the computer. Most people drew ones like this. So as more people interacted with the game, the computer didn't even recognize these. Latent bias. For example, if you were training a computer on what a physicist looks like, and you're using pictures of past physicists, your algorithm will end up with a latent bias, skewing towards men. And selection bias. Say you're training a model to recognize faces. Whether you grab images from the internet or your own photo library, are you making sure to select photos that represent everyone? Since some of our most advanced products use machine learning, we've been working to prevent that technology from perpetuating negative human bias. From tackling offensive or clearly misleading information from appearing at the top of your search results page, to adding a feedback tool in the search bar so people can flag hateful or inappropriate autocomplete suggestions. It's a complex issue and there's no magic bullet, but it starts with all of us being aware of it so we can all be part of the conversation. Because technology should work for everyone.
So that was a very small video on basically human bias. So often we are exposed to one particular type of data, like they mentioned. Maybe what we've seen is mostly that type of a shoe. Maybe what other people have seen is probably heels. So that's what we're biased towards. But when it comes to machine learning, as we've been continuously mentioning in this session, it's heavily data dependent. So the data should not be of one format, rather spread out to be more inclusive and include all different types of formats. It could include different types of shoes, different genders of physicists. And when you're basically asking it to identify a human face, for you to give it a model to train or data for it to train on, the data should have people from different cultures so that it can train on it and understand better. All right, we'll move on to the next video.
Machine learning systems require lots of data to make successful predictions. What happens when that data is sensitive, such as people's names, credit card numbers, or medical histories? Sometimes, sensitive data is needed to train a model so it can make accurate predictions. But at the same time, this data must be carefully protected. This is the challenge of machine learning privacy. Let's look at an example. Suppose you create a machine learning model to diagnose illnesses based on a person's symptoms. Someone who reports a stuffy nose and a cough might receive the diagnosis, the common cold, whereas someone else with the same symptoms plus a high fever might be diagnosed with the flu. Plenty of other factors might influence the diagnosis too. Does the patient have a medical history of similar symptoms? Did she recently travel to another country or spend time on a farm with livestock? Are other family members or roommates sick at the same time? To train this model, you could feed it information about thousands of people and their symptoms, medical records, and demographic information. This data includes plenty of personal information that needs to be kept private. In addition, the data sets involved might contain other private information not directly relevant to medical diagnosis, such as patient contact information or the credit card numbers used to pay healthcare providers. What steps should you take to protect user privacy? Step 1 is to gather and select only the data that your ML system needs to achieve its goal. The less private data you have in the first place, the less you need to protect. This might seem like common sense, but it takes effort. It's easier to copy a whole database than to spend hours removing the parts that you don't need. Step 2 is to identify any data in your datasets that may be sensitive. For example, people's names, addresses, telephone numbers, email addresses, government ID numbers, and other personally identifiable information, or PII, should be kept private. Another type of private information is user-generated content, such as email messages, YouTube videos, blog posts, and any other content created by known individuals. Be sure to work with your product counsel to determine which types of information are considered private and how to handle them. You also need to make sure you have permission to use the data and whether the data has other privacy restrictions. Be sure to work with your product counsel here as well. Step 3 is to protect the private data. You can do this by controlling access to the data and your ML model, or by altering the data so it's not recognizable anymore, or both. Privacy is a critical concern in machine learning. When you maintain privacy, you build trust with users and protect your company's interests.
So that was all about privacy in machine learning. So like I mentioned, machine learning heavily depends on data. And sometimes the data that we have to use will involve some personal information. So like they mentioned, if you're trying to find out the symptoms of a particular disease, you will go through endless hospital records. Now, hospital records will have a lot of other details that are not really important for your classification. Like they mentioned, it might have credit card number, your Aadhaar card number, so many other different things that are not important. So it's very important to not use these data that is private. And okay, so in some cases, what happens is that you will need this such kind of data. Maybe there is some case where you do need a credit card number to, let's say, predict something. You use it in some model. So what you have to do is take precautions with that. First, gather permission if you're allowed to get that data, and once you're allowed to get that data, protect it and use it wisely. Oh, okay. So Lakshman has actually asked a question. For a project which includes applications of ML in it, requires much more cloud storage. Isn't it a disadvantage of ML? If not, okay. So Lakshman, the reason cloud is used, so cloud is used to tackle with larger data. Cloud is a platform that's used to tackle with larger data. And one, yes, so you can think of this as a disadvantage of ML. You're right. So lot of data is kind of a disadvantage of ML, but we do have places like cloud storage. So especially in this day and age, we don't worry that much about space because we have cloud storage. Because we have cloud storage and we don't store it locally everywhere, cloud storage is a way where you can store multiple data, and you can also make sure that this data is preserved properly. That if if you store it all in, let's say, one computer and it's local, one, you're occupying all the space in that computer. Two, if that computer crashes, all of your data will be gone. But with cloud storage, what is happening is that gets stored onto the cloud. So even if your computer crashes or your local system or anything crashes, you still have the data preserved on the cloud. So the cloud is a technology that helps you handle this larger data. And you're right. And a disadvantage of ML you can think of is the large amount of data. But procuring that data is basically helping you ease out a problem. It's helping you solve the problem in a faster manner. So that is one advantage. So it basically balances it out, if you ask me. And plus you have, like I said, cloud, which helps you deal with this large data. Hope that was understandable.
Yes, ma'am. Excuse me, ma'am.
Yeah.
So my doubt is, ma'am, for ML, we have to train a lot, ma'am. So if we have to show, suppose if we are making to learn ML about a tiger, how a tiger looks or a carrot looks or tomato looks, it's kind of different shapes and different models, ma'am. So it looks in the different models, maybe in sometimes. So doesn't it take a lot of effort to make ML learn all these things, and it consumes a lot of times and effort of a human to make ML learn all this?
So, like I mentioned, we are not making the ML learn anything. All we have to do is give it the data. It's learning from that data on its own. You're right. It does take a lot of time. If you actually sit out to code out an algorithm and for like machine learning, and then you take data, it is definitely going to take some time to train on that, because it will definitely take some time to learn that. Think of it in this way. You basically have maybe let's say a baby cousin, and you're trying to teach your cousin how to identify the color red. So what would you do? You will start bringing many objects that are red. You'll get a red color pencil and say, okay, what color is this? This is red. Then you'll get an apple and red color apple and say, what color is this? This is red. Then maybe you have a red color bed sheet. So you'll get that and say, what color is this? This is red. This is exactly what we're trying to do with the machine learning model. We're saying, okay, here's all the data. Now use this data on your own and learn from it. We're not explaining how it is red or what makes it red to a baby. We're never saying that. We're just showing a color and saying this is red. So that similarly, if we're showing the image of a dog and we're saying, okay, this is a dog. Now you learn from here that it's a dog. So the machine learning model looks at it and learns from it. So there is some effort put into it, but the machine is doing it all on its own. Humans, we don't have to do anything.
Okay, ma'am. Thank you. Ma'am, one more doubt, ma'am.
No
how ML is, as we have seen in the video, ma'am, I have seen like a person is holding a mobile phone and we have using a ML in the mobile phone. How it is, ma'am?
ML in mobile phone, so there are different types of models that are, it depends on basically what you're using. So let's say you're using Gmail. So Gmail automatically has a spam classifier with it. So it uses this spam classifier to distinguish between spam and non-spam emails. Let's say you're using Instagram. It's able to tag people on its own. So that is machine learning that's involved with the particular technology that you're being used. So with different technology, like let's say Gmail. So Gmail has its own technology that involves ML. Instagram has its own technology that involves ML. Now, these technologies that involve ML is helping you accomplish the task there for that particular app or for that particular, let's say, email storage service and things like that.
Okay, ma'am. Thank
No problem.
Yes. Then, how an AI works different from ML?
Okay, so the important thing to learn, and this is actually the starting point of the next session, is that AI, machine learning, is actually a subsection of AI. So I'll just maybe share my screen. Obviously I will go over this again in the next session as well. But let's look at this. So machine learning is this, and this is artificial intelligence. So artificial intelligence, think of it as a big umbrella. Under this large umbrella, you have machine learning, and under that you have deep learning. So artificial intelligence, what is the purpose of artificial intelligence? Artificial intelligence is something that helps you automate things. Humans right now want to automate everything. They don't want to do anything manually. We're trying to automate things. So artificial intelligence is the process that allows you to automate everything. Machine learning deals with a method or deals with basically how you can automate this. How can you classify a cat from a dog? How can you identify the color red? That's what machine learning does. Now, deep learning is the same as machine learning. It's just that deep learning, if you have lot of data, maybe machine learning may not give you accurate results. So deep learning has better, let's say, algorithms within it that allow you to classify cat from a dog or things like that. So when you have larger data, you use deep learning. So that's the difference here.
If we are making ML to learn something, and how can we can see the results from ML, ma'am? In what way are the major ways? High rate in what can be the results achieved from the ML, ma'am?
Understood. I understood what you're asking. So you're asking basically how can we perceive that the machine learning model is giving us the results, right?
Yes, ma'am.
So like we spoke about, there are three phases in machine learning, right? Idea to implementation. So one, you have data, then you have the model, and then you have production. So when you think about model, what are you doing in this model phase? So first, you're giving a set of data for it to train on. Then you're giving some more data for it to validate itself. That, like I said, basically think of it as studying before the exam. Then you do something called a testing phase. So a testing phase is, just think of it as a final exam for the machine learning model, where you're giving a lot of models to it. Then what you're seeing is, so you know what's a cat, you know what's a dog. You're just checking if the model is correctly giving you the output, is this a cat, is this a dog? Then what you do is, you'll count the number of correct predictions it does. How many times does it correctly predict a dog? How many times does it incorrectly predict a dog? And based on these numbers, you find certain percentages. So this is known as accuracy of a machine learning model. So that's what you do. So you take, when you test the model, it will give you certain answers. It will give you that, okay, have you this image you've given to it? Okay, is this a dog? It will predict as a dog. Maybe you'll give it a dog, it will predict it as a cat. So that could be the incorrect prediction. So based on these results that the machine learning model is giving to you, you can understand how well it's performing. So you can look at the number of correct predictions and use that number and see, okay, there's let's say there are 40 images you're giving, out of which 39 were made correctly. That means your model is working very well. Most of the answers are right. But let's say you give 40 images for testing and then only 5 were predicted correctly. That means there was something wrong in your model. Somewhere it's gone wrong, so it's not giving you the right results. So that's how you can perceive how your model is doing.
Yeah, ma'am. What it in real world, how ML can be applicable, ma'am?
Sure. So, like even in the first video it was mentioned. So, like I mentioned, Gmail uses some spam classifiers, right? So the spam classifier is a way for you to predict what is a spam email from a not a spam email. So rules-based approach here would be very taxing. So machine learning is used here. Then you may have seen voice assistants like Siri, Alexa, Google Home. You can just say, hey Siri, what is the weather today? And it will give you the weather today. So that is all machine learning. That's how machine learning is used. So these are some instances. Or let's say that, your credit card suddenly gets blocked and you don't understand why it got blocked. And then you realize that there was a fraudulent transaction. Now, how did the bank exactly know that this is fraudulent transaction? They don't monitor every single transaction made by every single human registered in their bank. That is also a machine learning model. A machine learning model tries to identify which was a fraudulent and non-fraudulent transaction. So these are some real-time ways in which machine learning is used. So that's all for the session today. Thank you all so much for joining, and thank you for staying until the very end.